Hello, everyone. I'm Beinan from Twitter. I'm an engineer in the interactive query team. Okay, let's start. So today we will cover, start from a quick introduction for Presto DB, and then I will share some user story in Twitter, how we are scaling up Presto DB. Okay, let's start. What's the Presto DB? Actually, we are using Presto DB as a distributed SQL engine to query your big data. The customer can use the standard SQL to query their data set on HDFS, Kafka, Druid, and etc. The Presto is designed to be interactive, which means we expect most query can be returned within a couple of seconds to a couple of minutes. And by using Presto, we are able to access petabytes of data. In Twitter, we are using Presto to query, I think, more than 100 petabyte dates every day. The Presto is an open source project hosted on GitHub, so feel free to make any contribution or ask a question about GitHub. Yeah, I have a question here. Is Presto a database? I might be say yes, because it looks like a database, but definitely it's not something like the traditional RDBMS like MySQL, like Oracle. The Presto is a storage independent query engine. Which means usually we make Presto on top of the real data source like MySQL, like HDFS. Yeah, it's more like a service actually. What makes Presto DB different? I think for these three reasons. The first is the scalable architecture. You can scale up very easily. I can introduce later. And also we have pluggable connectors, which means Presto can support multiple data sources. And also we have really good performance when using Presto DB. For the scalable architecture, just because in Presto we only have two rows, a single connector, a single coordinator with multiple workers. It's not like some other big data query engine. They have maybe maybe 4 or 5 rows, but for Presto, it's super easy. It's super easy to deploy. Only one coordinator, and then you can scale up and scale down by adding or removing the workers. But we're really seeing some limitation on this. The scaling up to 1,000 workers because we only have one coordinator, which makes the coordinator a little bit vulnerable when we have more than 1,000 workers. But even with 100 or 200 workers, the Presto is still super powerful. It can fit in the web scale, the companies like Facebook, Uber, Twitter. We are using Presto every day for the analytical SQL works. And as I mentioned, we can use the pluggable Presto DB connectors to support multiple data sources. But the really powerful things is not just access this data source. It's we can use just one SQL to join the data from multiple data sources, which means you can just make a SQL to select some data from MongoDB and join your Hive table on HDFS. Even more, we can write the data. We can write the result from the query. We just talk about. We can inject the data, the results to some other data source. Let's say in Druid, which means we can just use Presto to select some data, maybe from some Hive tables from MongoDB, and write the data, make a data ingestion to some other data source like Druid. In Presto, that's why I said Presto is a database. So in Presto, we just mapping the connector to the catalog, and then the data set or the table in Presto just like a table, just like MySQL and Oracle. You can just use show tables to get all the tables, and you can just select something from a table, and you can show the columns. You can do everything just like a SQL database. And in Presto, the most popular connector is the have connector. By using the have connector, you can just make Presto to scan or query the data directly on your have data warehouse. You don't need to do any data ingestion. The Presto can just call the have meta store to get the metadata and mapping the have table as a Presto table. And in this case, actually Presto is not using the compute power of Hive or Hadoop. We do the computation within Presto, but we just use the data on HDFS and the metadata in the Hive metastore. Let's talk about something about why Presto DB is fast. Firstly, I think that the major reason is Presto is make everything in memory. So all the intermediate results will be stored in the memory. It's not like something like a MapReduce or Spark. Something might be stored in the HDFS or something. And also, Presto is using a pull model. We consider the MapReduce as a push model, which means you have to, for each step or for each stage, you have to wait for the prior step or stage finished, and then we can proceed as the next step. But in Presto, we keep pulling the data from the previous steps. We don't have to wait. It's more like a streaming. It's a streaming process. Also, Presto, we have some optimization on the columnar storage, like the data format I mentioned, like Parquet. The Presto can also perform very well on the row-based storage, but we can do even better on the columnar storage. And also in Presto, we have bytecode generation, which can speed up the execution in the JVM. So let's share something about how Twitter scale Presto DB in the cloud. Let's revisit the how we use Presto DB on our private data center at Twitter first. In Twitter, we have a long history of using Presto. I think we use Presto for more than 6 years. So definitely a single cluster cannot satisfy Twitter's needs. So we have more than 6 Presto clusters, and we have more than 2,000 Presto workers. And we processed more than 10 million queries last year. And here's some architecture of how we use Presto in Twitter. So actually, the Twitter is using the Presto from some client like Zeppelin, Tableau, or some JDBC driver, or some local tools like a DB visualizer. We place Presto side by side with Hive and Spark SQL. So at the very beginning, we designed Presto focus on some small query or lightweight query, but during these 6 years, more and more people found, okay, Presto is much faster than Hive. So now in this diagram, more than 99% of query actually goes to Presto. Our customers that don't like to use Hive and Spark SQL. Yeah, because if some tool become a dominant tool in the company, so everyone just want to use it because it's easy. And also, we are just using the Hive metastore as to store the information of each table, and the data storage is still on HDFS and GCS. The user using Presto for multiple use cases like the ad hoc query, like the BI tools, like dashboards, almost everything, and even some critical ETL jobs. I have said the Presto is designed for the interactive query, but the user still want to try this SQL for their cron jobs or for their ETL jobs. Yeah, it's okay, but the user should handle the retry logic on the client side. So here's the thing, because we can see some something happen if we have a really large cluster, say we have a cluster more than 1,000 workers. So we just, as I said, we put more clusters. We deployed a dedicated cluster for our customer, like a separate cluster for maybe for the cron job, a separate cluster for the Tableau users, and also maybe a separate clusters for Zeppelin users, something like that. So then we can keep for each cluster, we have a smaller size, maybe just 500 workers or something. But you know, the case is the user pick up which cluster they want to use, but they make a lot of difficult for us to maintain the clusters because this cluster is running on different hardware. Some cluster running on the containers like Docker. Some cluster just running on the bare metal machine. So make a lot difficult to us to tuning these clusters. And also because for each cluster that have a single coordinator, which makes the availability issues, the Presto is down during the deployment. So when we are migrating our compute power from private data center to cloud, we redesigned the architecture of our Presto clusters. So we put a Presto router in front of our sub cluster. So we just have a single unified entry for all of the Presto clusters. The user just talk to the Presto router. Presto router is also an open source project made by my teammates Hao, Luo, and me. So we open source this project, and the user can just use it. It's just like the usage of this Presto router is transparent to the customer. It just looks like a single cluster. The user sends the query to the Presto router, and the router will redirect the query to the subclusters. So then we have an aggregated UI for all of these clusters, and we can split the waiting queue on each subclusters, and the total compute power can be much higher than a single cluster. And with this Presto router, we can also make something like a rolling deploy, and we don't have a single point failure anymore. The other thing we made is we have intelligent scheduling on the Presto router. It's another open source project made by my teammate Chun Xu. He introduced some AI machine learning mechanic for the routing logic. It's not just a simple round robin. We predict the resource usage of each query and send the heavy query to the spare clusters, and we can skip sending the query to the basic cluster, something like that. So from the customer side, they can also use this predictor to integrate this predictor to their web UI, like Zeppelin. They can get a quick understanding of their CPU usage or the memory usage of the query before the start execution. Here's how the AI predictor works. The Presto will collect the logs for each query, and for each log entry, it will contain the query, the SQL syntax, the SQL statement, and also the CPU usage and the memory usage. So the AI tools train the model based on this data, and for each query comes in, it can based on the model we trained to populate the results of the CPU time and the peak memory bytes. Here's the simple UI of the query predictor. We can see for this query, it can give you a result of the CPU time and the peak memory bytes. Yeah. Based on the early research of our the query logs, we can see the distribution of, or we can see the proportion of each query. It just lists the peak memory bytes here. So we can see we have a large number of the tiny queries, which means the memory usage is less than 1 megabytes. It's really tiny for Presto, but we also have a large number of huge query, which means the memory usage is bigger than 1 terabyte. Because usually the total memory for each Presto cluster is around 20 terabytes or 30 terabytes, which means for this kind of query, we have to schedule very carefully. Otherwise, it will block the execution of other queries. It will take too many memories. In the early stage, we focus on do the optimization on the middle range of the query, which means the memory consumption is between the 1 megabytes to the 1 terabytes. But in the future, I think in Twitter we will focus on more on the tiny query and the heavy queries. We would like to provide a better SLA for the tiny queries, which means we want to provide the SLA for this query to be within 1 second. By doing so, we need to push down the SQL. We can see push down the compute from Presto to Druid or Peanut. We have the Druid and the Peanut connector there, and we can easily to push down the SQL from Presto to Druid, and we can see some very low latency within this approach. We can see the latency is below a couple of 100 milliseconds. Most query can be finished within 200 milliseconds. It's super fast. And also, if we really want to provide a low latency SLA of Presto, we also are using the ZGC instead of G1GC, because G1GC is really good for the high throughput, but the ZGC will provide a much better guarantee for the low latency. And also for the heavy query, we might introduce the Presto on Spark. Yeah, we can introduce this kind of a query, go to the Spark SQL to have more fault tolerance. But most users just love to stay on Presto, so we can use Presto on Spark, which means for a single cluster, we can easily to get more than 1,000 nodes. It's a new project in Presto. We can just take advantage of the resource manager of the Spark. We can highly scale up to the Presto to get a more powerful single cluster. Yeah, I think in the future, in the Twitter, we can combine the Presto and also Presto on Spark together to handle the lightweight query and also the heavy query.